This is the last video for the review for test 1. These last 3 problems all deal with rational equations, which means you have fractions in the equation. This first example has denominators that are whole numbers, which is a little different than what you'll see on 28 and 29. When you have fractions in the equation, whether they have whole number denominators or they have variable denominators, you need to get rid of the fractions. And the way you do that is to multiply both sides by the least common denominator. The least common denominator here is 24. Now when I say both sides, what I really do is I multiply every term by that common denominator. And the reason you do the every term is this. This right side is x over 3 minus 5. I would need to multiply both sides by 24. In doing that, that means I'm going to have to distribute 24 to both of those terms. So I go ahead and do that multiplying right off the bat and not deal with the parentheses on the outside. If you have chosen your common denominator correctly, then the denominators will disappear. They will be absorbed by the common denominator. So 8 goes into 8 once, 8 goes into 24 3 times. I'm left with 3 times that x that was already sitting there. Just gives me a plain old 3x, and the fraction is gone. Same thing over here. 3 goes into 3 once, 3 into 24 8 times. 8 times the x that was sitting there makes 8x. And don't forget to do this right here. There is no fraction to cancel out, but I do need to do 5 times 24, which makes 120. Now you have a basic simple equation. There are no more fractions. So this is just a matter of getting your x's together on one side. So the way I'm going to do that is subtract 8x from both sides. So I have negative 5x equals negative 120. Divide both sides by negative 5, and x is 24. Which you can plug it back in for each of those x's and check. Now this one is a little bit more complicated because notice the denominators have variables in them. Also, this denominator over here is a trinomial that needs to be factored. So that's our first step, is to factor this trinomial. So this will be x in the front. The last sign is negative, so one of these is positive, one of these is negative. And now you say to yourself, what multiplies to give me 10, that subtracts to give me 3, which is 5 and 2. And this is no big coincidence that this and this happen to be part of this denominator. You are not going to end up with a huge denominator with 4 or 5 different terms. Most of the time when you've got these two binomials, they are going to be the way that the trinomial factors. The next thing I would do, just to be safe, is change this to plus a negative. Get that negative sign up close to the 4, otherwise you might make a sign mistake when you multiply by the common denominator. So the common denominator is this x plus 5 times x minus 2. The biggest pain on this is getting this written 3 times next to each term here. So x plus 5 times x minus 2. And then I'll try to squeeze this in right here. X plus 5 times x minus 2. So what I've done there is I have multiplied both sides by the common denominator. And the way I do that multiplying is I actually multiply it times each term. So now I just have to look at this right here. Look at nothing else. Cover it up on your paper if you have to. I'm multiplying the common denominator times that fraction. That goes away with that part. And I just have to do x plus 5 times 1, which is x plus 5. Now I'm just going to look at this. So that's plus. And this is the reason I brought that negative up close here. When this and this cancels, it is negative 4 times that parenthesis, which is negative 4x plus 8. Then over here on the right side, I'm looking at this, and all of the denominator cancels, and I just get a plain old 7. So by multiplying by the correct common denominator, I have made the fractions go away, and now I have a reasonable equation to solve. So this is negative 3x plus 13 equals 7. Subtract 13 from both sides, and we have negative 3x equals negative 6. Divide by negative 3, so x is 2. Now there's something we need to do on this one that we didn't have to worry about on this one. These denominators were both whole numbers. These denominators contain variables. We cannot end up with 0 in the denominator, so you have to take your answer and plug it back into the original problem and see if anywhere creates 0 in the denominator. So if I happen to plug 2 in right here or over here, I'm going to get 0 in the denominator. I'm not allowed to have that. That tells me that 2 has to be thrown out, and therefore my solution is the empty set. Now, rather than checking at the end, another way to do this is from the very beginning, before you do any work at all, take a look at your existing denominators and see what numbers would be thrown out. X minus 2 in the denominator tells me x is not allowed to equal 2. X plus 5 in the denominator tells me x is not allowed to equal negative 5. Those are known as restrictions. So our domain can be any x except 2 and negative 5. Why didn't I look at this one? Well, this one, remember, factored as x plus 5 times x minus 2. So I've already got that one covered. So that's the other way to go, is to know from the beginning what your restrictions are. And if you happen to get one of those numbers as your solution, you throw it out, and we've got empty set. Pretend for a second we'd gotten x equals 2 and x equals 6, let's say. Well, we would throw the 2 out, but we would still keep the 6. So that's a possibility. If you get 2 answers, you might throw one out and keep the other one. So let's do the same thing we did with the last one. Change this to plus and negative. Take a look at this and factor it. And if you don't want to apply a whole lot of thinking, just right off the bat, think, well, maybe it's x plus 4, x minus 2. Now, double check by foiling to be sure that that really works, and it does. That means x plus 4 times x minus 2 is my common denominator. So I'm going to write that multiplication next to each term. And before I actually do that, let's go ahead and talk restrictions so I don't have to do any erasing. X minus 2 means I have a restriction x is not allowed to equal 2. X plus 4 means I have a restriction of x is not allowed to equal negative 4. Now where do those restrictions come from? It comes from the fact that you are not allowed to have 0 in the denominator. So we take each denominator and we set it equal to 0. Seems kind of silly. We don't want it to equal 0, so we set it equal to 0, but the reason we're doing that is to figure out what number would create 0 in the denominator, and then do the same thing with the x plus 4. So that's why we've got those two restrictions. So now we're ready to multiply through and get rid of our denominator so that we can do some canceling out. So over here, x minus 2 cancels with x minus 2. I just have to do x plus 4 times 1, which is x plus 4. Over here, x plus 4 cancels, but I have to distribute negative 2 through that parenthesis, which is negative 2x plus 4. And on this side, the entire denominator cancels, and I have 2x minus 1. So with one good move, we have gotten rid of all of the fractions, and now I need to combine up over on this side. Negative x plus 8 equals 2x minus 1, and our strategy is just get our x's on one side and our numbers on the other. So if I add x over here, I get 3x. If I add 1 over here, I get 9. Divide both sides by 3, and x equals 3, which is not in our list of restrictions, so x equals 3 is our solution.